Right, guys, this is my recording for Exponential Equations. As I said in the previous email, I've had trouble trying to work out how I would show this part of the course on videos because the iPad obviously doesn't have any Texas Instruments calculators apps. I think I found a workaround. Hopefully this works out okay. The only problem is I need to do the videos perfectly or in one go. So if I make a few sort of mistakes. I don't have a script for these. I'm doing it straight off scratch. Um, Hopefully it's not too bad. And yeah, they're videos that I'm doing, so you just have to deal with it anyway. So an exponential equation is basically the end result of what we've been doing so far. We've been looking at exponential functions, how they work. An exponential function shows the relationship between x and y, given that the variable x is the power of something. So an exponential equation is when a function equals something. So an equation is just um, an expression that has an equal sign, and an exponential equation is an equation where the unknown variable is part of the exponent, also known as index or power. So here we have an exponential equation. This is an exponential function. Not previously, we've seen something like y is equal to 2 times by 3 to the power of x. Now we're saying instead of y is equal to that, we're saying 2 times by 3 to the power of x is equal to 10 instead. So 10 is taking the place of y, and we're trying to find what x is in these equations. So this is an exponential equation. It has an equal sign, and the variable x is an exponent. So basically it's saying, just like I said before, the function 2 times by 3 to the power of x is equal to 10. And so the whole purpose of this next part of the course is working out what power of x makes this function here equal to 10. So the way we do that is not through algebra. We are going to use the graphics calculator to do that. So you have no option, you need to have a graphics calculator. And you're going to be using the graphing functions of it. So the solution for this, the solution for x, is the point at which the graphs cross, or in other words, the point at which each side of the equation are equal, and that is basically where the graphs of both sides intersect. So if we were to draw a graph of y is equal to 2 times by 3 to the power of x, and also another graph of y is equal to 10, and we see where they cross, the x value of that point where they cross is the solution. So I'm going to take you step by step through solving one of these. There's no other easy way to find out how to do this other than to step you through. Instead of reading you out these steps, we're going to start with an example to start off with and see these steps in action. Okay, there's 6 steps to it using your calculator. So we're going to use those 6 steps to solve this. 2 times by 3 to the power of x is equal to 10. So step 1, press the button y equals next to, y equals next to y1 equals, enter one side of the exponential equation. This tells the calculator to graph whatever you've entered next to y1 equals. So what I've told you is that the solution to this is where both sides, a graph of both sides intersect, or where these two sides equal each other. So if we substitute in where one side is equal to y and the other side is equal to y, we can find the two graphs and see where they cross. So I'm going to put the left side in first. 2 times by 3 to the power of an x, the variable is this button here. So that's my first side, that's my first graph that I'm going to be drawing. It's drawing the left hand side of the equation. Now step 2, next to y2 equals, enter the other side of the exponential equation. This again tells the calculator to graph whatever you entered next to y2 equals. So what's the other side of the equation? Is equal to 10. So I'm basically putting y is equal to 10 as my second graph that I'm putting in. Done. Now just make sure that these two are highlighted. The calculator will draw everything that you've told it to draw, so you need to tell it to draw both of these graphs. So step 3, press the button graph and your calculator will draw both graphs. So you'll see this button here, graph. The calculator's working. There's the first graph. That was the y1 equals, and there's the second graph there. Okay, so step 4, you need to be able to see where the two graphs cross the intersection. Now you can see that the curved line and the straight line, where y equals 10, looks to be crossing there, but it's not quite clear. Let's see if we can scroll up. It's quite slow. Oh, wait, let me scroll up. So unfortunately it hasn't centered on the graph that we need there. So often the calculator is going to be zoomed into an unusual level. This is a pretty good level, but it's always pretty good to start off at the standard. So to do this, you go to zoom and press Z standard. So scroll down to there, and that opens the basic window. I think it already was that. So see, it looks the same. If I can't see the intersection yet, I can here, but I'm just going to show you how you would do this. If you couldn't see the intersection on the screen, you can automatically zoom and get the calculator to try and work out the best way to zoom by going zoom and going down to zoom fit. And the calculator tries to be smart and select a zoom level where it definitely shows where the graphs intersect. So hopefully, okay, that's not even that much better. Now it's just a line at the bottom, but you probably definitely, actually, I think it guarantees that you're going to have the intersection on there somewhere. For you to get the intersection, you just need to make sure that it's visible on the screen. So I'm hoping that that zoom fit has found the intersection there on the screen somewhere. Now we just need to find and let the calculator work out where the intersection of the two graphs is. How do you do that? You press second and trace. Second, trace, select 5, intersect. Now it asks you what the first curve is, second curve, and guess. You just have to press enter for each. And then you're telling it, can you please find the intersection for me? And there it seems to have found it. The intersection of the two graphs is going to be x equals 1.464 blah blah blah, and y is equal to 10. Obviously the y coordinate of the intersection is going to have to be y is equal to 10 because one of those graphs is a straight line across, so y is equal to 10. So that's step 6. It tells you the coordinates. So I've used technology. Therefore, the solution of that equation x is equal to 1.46 to 2 dp is the solution to this doohickey here. Alright, so that is an example of using technology to find the solution to an equation. Basically all you're doing is graphing either side. You're graphing the left side, you're graphing the right side. You can see that here. If I go to the y equals, this is where you put your graphs in. I put the left side of the equation in, put the right side of the equation in, graphed it by pressing graph, set up a view where I could definitely see the intersection, got my calculator to find the intersection by doing second trace, told it the curves, and it solves it for you. Okay, and so the solution to the equation is whatever the x value is, which is that. So I've rounded it to 1.46. So hopefully that helps you out, and I'll see you in the next video.